Okay, hello friends. Now circular linked list. Now these two are the header files. Okay, and this is a structure where the structure name is node. The two components are there, data and next. Data is integer type and next is a pointer type where we store address of the another node. So here we are using safe references structure. Now type def is a part of the structure. So node is a ADT, abstract data type. Now this is the function insertion function, insert a data into the circular linked list. Two parameters are there, list and data x. Okay, so data you want to insert for and list is the address of the next. Next function is insert as a first. Insert as a first node means insert a data as a first node. Next function to search a node. Search a node. If the node is key is present, then it will return 1. If the key is not present, it will return 0. Next, so is a function to delete a node. Okay, you want to delete a node if the content of the node is data. So if a node contains this particular data, then it will delete from the list. It will remove from the list. Next, print the list, print the content of the list is the function of that particular operation. Now to count the number of nodes present in the list, we have to call this particular function, count node. Now main function, so start and temp. So start and temp, these two are the pointer type, node type. Okay, node pointer type. Now in start we store one address of the node. That means in start we store one node. Okay. So while one, infinite loop. To implement infinite loop we use while one. Now these are the options. So press 1 for insert, 2 for 1 for insert, 2 insert as a first node, 3 to delete, 4 to print the content of the list, 5 to search any need, 6 to count the number of node present in the list, 7 to exit. Now case 1 call insert function, case 2 call insert as a first function, case 3 call delete node function. Case 4 call list the content of the node, list the content of the or display the content of the list. Case 5 search function. Case 6 count function, call the count function, and case 7 execute. Okay. Now we can execute. Now enter the option 1 to insert. Now enter the data you want to insert. Suppose you want to insert 10. Okay, now you can see here the list is 10. Now you want to insert another data, press 1. Now you want to insert 20. Now the list is 10, 20. Now you can insert another 1 and enter the data to insert. Suppose you want to insert 30. Okay, so the list is 10, 20, 30. Now to insert, enter the data to enter as a first node. Now suppose you can insert 1. Okay, you can see here now 1 is a part of the list and it is the first data, first node. Next 3. Before deletion of the list, 1, 10, 20, 30, enter the data to delete. Suppose 1 we want to delete. After the deletion, the list is 10, 20, 30. Now we can delete the 30 also, 10, 20, 30 any also. Suppose 4 to print the content of the list, display the list. Okay. 5 to search, enter the data you want to search for. Suppose to check whether 20 is there or not. Yeah, 20 is present. Now press 5, enter the data you want to search for. You have to check whether 70 is there or not. Okay, 70 is not present. Okay, and 6 to count. Okay, so 3 data present. So you can see here that 3 data present, 10, 20 and 30. Now 7 to exit. Okay.
Okay, hello friends. Now already you know what is singly linked list. So head is the first node. Here we store address of the first node. So uh, first node, second node, third node. Okay, or last node. Here here it is a data part and it's the next part. Okay. Now assume address of this particular node, say x2. Assume it is x4. Assume it is x6. So here you can store address of the first node, that is x2. Here we can store address of the second node, that is x4. Here we store address of the third node, that is x6. Now if it is simple singly linked list, though the last node is null, the address part of the last node should be the null. So address part of the or next part of the last node will be the null. This is single linked list. Now in in circular linked list, last node we store address of the first node. Suppose address of the first node is xh, so here we store xh. Okay, that means if it is a head, okay, it's a first node, second node, last node. Here addresses were x2, x4, x6. Here should be x2, x4, x6. So instead of storing null, here we store address of the first node, address of the head node, as though it is xh. So we can put xh here. That means it is like that. Okay. Now application of circular linked list. The application is we may use for CPU scheduling or time sharing, CPU scheduling in time sharing basis. Okay. Now suppose three jobs are there: job 1, job 2, job 3. Now time required to execute 2, 4, 6. So it will CPU give time each and every job in unit time. So it will execute the nodes. Now if any of the job is finished, so you can remove this particular job and it will execute further remaining jobs. Okay, so we may use circular linked list for the CPU scheduling. Okay, time sharing basis. Now we can see the structure of the program structure of the circular linked list. Now circular linked list, here we discuss about the insert as a first, delete, print, search, count operations. Now these two are the header files, stdout.h and stdlib.h. Now this is the structure definition. Now type def is inside the structure. So node C data, in this particular structure two components are there, members are there, data and next. Okay, so if it is a structure, two parts would be there, data part and the next part. Now data part we assume it is integer type and next part is a pointer type where we store address of the another structure. Okay, now type def is inside the structure, node is a ADT, abstract data type. Now through node we can declare the structure variable. Now you can see this is the insert function. Okay, insert function. Now you can say this is the insert as a first function. These are the lines for insert as a first function. Clear? Insert as a first, insert a node, insert as a first function. Next, search a node. Okay, searching a node. Now this is nothing but our delete a node from the circular linked list. Okay, and this particular functions is a print the content of the list. Print the content of the list. Okay, now it's a main function and we define all the function before the main function, that's why I don't require that function declaration. Now start and stem. Start is a starting address. Okay, here we store address of the first node. Okay, now start is equal to node asterisk malloc size of node. So that means what? Start one pointer type where we store uh, address of some memory. Okay, and uh, address of the memory. So suppose address of this particular memory is say xs, it is xs. So that means in start we store address of this particular memory portion, that is xs is should be here. Now start next. Now start is what? So from now and then we use this particular portion as a start, but practically start is a pointer type. So where you store address of the node type, node is a structure, okay, and start is equal to, that means using this particular statement we can create one memory portion, and equal to means address of this memory portion should store in start. Clear? Now start next. Now start, where referring start means where we using start we can access this portion of the memory, okay. Now start next means what? This particular portion, here you store start. So in start we store address of this particular, assume it is xx. Now here it is xx. Okay. Now these are the function. Press 1 for insert, 2 for insert as a first, 2, 3 for delete, 4 to print, 5 to find, 6 to count, and 7 to exit. Okay. Now enter the operation. So if case 1, call insert function. If case 2, call insert as a first function. In case 3, call delete node function. In case 4, call print function. In case 5, call the find function for searching any data. In case 6, count how many nodes are there, and in case 7, if you press 7, then exit from the loop. End of this switch statement, end of the while statement, and end of the main function. Okay. Now we can see here. So execution will start from the main function. This is the main function. So we have created one start point. So assume it is a start. Okay. So forget about this particular portion. Now it is, assume it is a start. It's a start. Okay. Now we just press insert 1. Okay. And insert function we pass two parameters, start and data. Okay. So data we want to insert for. Now you can see the start function. Now this is the start function. Okay. Now node asterisk list and data x. So data x we want to store. Okay, and here we pass the start. Okay, so assume it's a start. Okay, now it is list. It is here we are using call by reference. Now node asterisk start is equal to list. Now here we are using another variable start. That start is a local function, a local variable. So start is equal to list. So start is this one. Now list next is not equal to start. List next. So initially first time if no data is present, then assume last and state list both are same thing. Okay, and here we store address for the first, say xx. So in start, first time we pass the address of the head, address of the start node. Okay, so in start address of the first node is there. So address of the first node is what? Xs is the address of the first node. Okay, now list next is not equal to start. List next is not equal to start. The condition is false because it is start. So in start address, in start xs is there. Okay, and xs is the starting of the first node. Now list next. So list next means here we store. Now from this particular statement we can create one memory portion. The two parts are there, the data part and the next part. Now list next means here we store address of this particular portion. and list is equal to list next. Now list is equal to, now the list is list next means what? List is pointing this particular node. Okay, list data is equal to data x. Now data x you want to store for, suppose you want to store 5, so we can store 5. Okay, uh, and list next is equal to start. Now in start we hold address of the first node always. Okay, list next means here we store address for the first, so it is xx. That means we are doing this one. Okay, now once again we press 1, we want to insert, and we are passing the start address and the data. Assume we are passing say 20. Okay, now start address xx it is already, and say data is 20. Okay, so once again list, we are passing the start and list, so list hold address of the first node. Now this is the situation, list store address of the first node. Start, here start is a local variable is equal to list, so start is the same thing. So in start we store hold address for the first node, that is this one, this particular, so start is indicating this one. List next not equal to start. Now this time list is equal to this one, list next, here not equal to start. In start the content is xx. Okay, now but here xx is not there, address of the other node is there, the condition is true. List next not equal to start, yes, list next it is say x5 is there, so here x5 is there, so x5 is not equal to xx, condition is true, list is equal to list next. Now list is equal to list next, in list next address of this particular node is there, so now list is this one. Okay, now list next not equal to start, list next not equal to start, now the condition is false because here address for the first node is there, x is there. Clear? Then in list next we create, using this particular statement we create one memory space. Okay, and in list next we store address of this particular, and in list is equal to list next, now list is equal to this one. Now list data is equal to data x, suppose 20, and list next is equal to start. In start xs is there, we put xx. Now still it is circular linked list. Okay, so is it clear how to insert a data now insert a data as first node. Now we press 2, we press 2 to insert as a first node. So here we pass address of the starting node. So the situation is like this. This is the start node. Okay, and this is nothing but the list. Okay, now two nodes are there, 5 and 20. 5 and 20. So 5. So if it is xs, if it is x5, if it is x20, here should be the x5, x20 and xx. Here we store address of the first node. Okay, now this is the situation. Now to insert a node we have to create so node, new node, so you just create one new node here. Okay, and assume it is new node, enter the data to enter the first node. Now suppose in new node we store data, say 1. Okay, new node data, this is the data part, this is the data part, this is the next part. Now new node next is equal to list next. So if this will be the first node, this will be the second node. In this particular portion we store address of this particular node. Now where how to get this address of this particular node? From this list next, from this list next. So new node next, here we store list next, content of the list next. So in list next x5 is there, that means now we are storing x5 here. Next we have to modify this particular part, here we have to store address of this particular node. So list next is equal to new node, So if it is new node is say x1, address of this node is x1, so now it is x1, that means we are connected this one, that means this link is not there. Okay, so now this node we assume as a first node, treated as a first node. So first node, second node, third node. Okay. Okay. Now next is mm, searching a node. Next is assume it's a searching a node function. Now you can see here, if press 5, enter the data to search for. Suppose we want to search for whether 5 is there or not. So find, we are calling the find function. So find will return 0 and 1. If the data is present, it will return 1. If the data is not present, it will return 0. So if flag, printf, if flag, if it is 1, then data is present. Okay, and else otherwise if it will return 0, then printf, the data is not present. Clear? Now you can see the search function. Now here we can say whether 5 is there or not, or 5, yeah, 5 is there or not. Now we are passing the starting, this is the first address, we are starting at, this is the start address. Okay. Both are indicating this first node, here where we store address of the first node. Now list is equal to list next. Now the data in this particular head node, no data should be there. No data is there, so we have to start from the next. So list is equal to list next. Now list is equal to this one, because in list next address of the next node is there. So now list is pointing this particular node. Okay, well, list is not equal to start. List is not equal to start. In start, address of the first node is there. Say address of the first node is x6. No, here it is x2. So condition is true if list data is equal to key. Now suppose you want to search whether 5 is there or not. Okay, now list data is equal to key. In list data it is 2, key no. The condition is not true. So do not execute this particular part, return 1. So list is equal to list next. So now the list is this one, list is equal to list next. So list is not equal to start, the condition is true because here x5 is there. Okay, and x6 is there, condition is true. List data is equal to key. Now list data, it is equal to 5 and we want to search for 5. Now the condition is true, it will return 1. And already you have seen that when flag receives 1, when flag receives 1, so if 1, printf, the data is present. Okay, next, delete a node. Suppose we want to delete a node and the situation is like that. Two, 4, 6. Okay, say it is x6, assume it is x2, x4 and x6. Clear? So here x2 is there, x4 is there, x6 is there and x6 is there. And this is the list mode, this is the list, this is the list, and node is equal to start. So start is pointing this one. So in start x6 is there and in list x6 is there. Now suppose we want to delete fourth node. Okay, now pointing this one, so that means there is a virtual link. Okay, list next is not equal to start. Now suppose you want to delete the fourth one. Clear? List next not equal to start. List next here not equal to start, condition is true. Here start hold x6 and list next is h2, the condition is true, not equal to yes. List next data, list next means what? This particular here address of content of this now x2 means what? This particular node. Data is what? 2, and we want to delete the node if that particular node contain 4. So list next data, list next data 2 is not equal to data, the condition is true, list is equal to list next. Now list is this one, that means here now the content of list is x2. Once again, list next is not equal to start. List is pointing this particular node. List next is not equal to start. Condition is true. In start xs is there, but here x4 is there. This particular condition is true. And list next data. List next means what? This particular node data. This particular node is not equal to data, but the condition is false because list next data is 4 and we want to search whether 4 is there or not. Whether 4 is there or not. The condition is false. So since we are using AND operation, so any of the if any of the logic is false, then the whole will be the false. Next, if list next is not equal to start, list next next is equal to start. No, in start xs is there, now it is x4 is there, so the condition is false. Temp is equal to list next. That means we create one temporary variable. So already we have created one temporary variable tmp. In tmp we store address of the list next, content of the list next. So list next means what? X4. So we just put x4 here. That means here we in temp we store address of this particular node. List next is equal to temp next. Now suppose we want to delete this particular node. That means what? Here we have to store address of this particular node. So how to find this address of this particular node? From this particular part. So list next here we store from the data, transfer from data temp dot next. Temp means what? Now this one is the temp next is what? X6 is there. Now here instead of storing x4, x content is now x6. Now this is pointing this particular node. Free temp means remove this particular part. Okay, now 4 is not part of the list. Now suppose you want to check whether we want to delete, suppose you want to delete 40. Okay, now the situation is now suppose you want to delete 40. So data is equal to 40. Okay, here it is equal to 40. Now this is nothing but our list, first time list, and the start also. So list next is it not equal to start. List next not equal to start. Condition is true because x2 is there, but it is start holds the xx. Condition is true. And list next data not equal to data. List next data is not equal to data. Condition is true because we want to search 40, but 2 is there. Condition is true. List is equal to list next. Now list is equal to this one. Now list next not equal to start. List next not equal to start. Yes, it is xx, and we are comparing with xs. Condition is true. List next data. List next data. That means 6 is not equal to 40. Yes, condition is true. 6 is not equal to 40. List is equal to list next. Now list is equal to this one. Now list next not equal to start. List next not equal to start. Now this condition is false because list next is equal to start. This condition is false. Come out from the list. Now list next is equal to start. List next is equal to start. Yes, the condition is true. The data 40 is not present in the list. Okay, the data is not present in the list and return. So obviously 40 is not part of the list. So that is the delete function. Now suppose you press 4 to print. Okay, so 4 to print. So here we are passing two parameters, start and start next. Okay, that means suppose so it is xx. Okay, say 2 4, xs is there, it is x2 and it is x4. Okay, so start is equal to, say this is the start and this is the list. Now if list is equal to start, so in start xs is there, in list x2 is there. Okay, so condition is false. Printf. Printf list data, so it will print 2. List is pointing this one, the data part is the 2 part, so it will print 2 next. Okay, and plist start, and so here we are calling the same function, so here we are using recursion, and this is the base case, this is the base case. Okay, and this is the recursive case. Okay, so it will print 2 next. Once again, list next is what? List next is this one, so now this is the list, so we are passing 2 parameters, start and list next. Okay, list is not equal to start, list is equal to start, the condition is false. In list, address of this particular node is there, which is x4, and here x in start xs is there, so the condition is, this particular condition is false, so it will print the list data. So it will print list data means 4, it will print 4. Once again it will pass start and list next, that means start xs and the list next. Now in list next xs is there, that means we are passing the same xx. Now recursively we are passing this, so list is equal to start, now the condition is true, so it will, if it is true, return, it will not print anything, it will return. So in this way we can print the content of the circular linked list. Now this is the count function, the last function. Clear? Now suppose the situation is this one, say 2 4. Okay, it is exist, it is list and start both. Here x2 is there, expose is there, and xs is there. Node list. Okay, in c is equal to 0, c is equal to 0. List is equal to start, list is equal to start, same. Okay, list next not equal to start, list next, this particular not equal to start, condition is true. Then c is equal to c plus 1, so the value of c is 1 because initialization of the c is 0, so instead of c is 0, now c is equal to 1. Okay, one second, list is equal to list next, now list is this one, list next not equal to start, list next not equal to start, the condition is true because it is x4, but in start xs is there, c is equal to c plus 1, now c is equal to 2. Clear? List is equal to list next, now list is equal to this one, list next not equal to start, list next not equal to start, now the condition is false because in list next xs is there and start is start hold address of the first node, which is xs, so come out from the loop. So so 2 nodes are there, and so that's why the value of c is equal to 2. So printf the 2 data present. Okay, so we'll print 2 data are present. Okay, and if you press 7, then exit from the list. And that is end of this particular video. Thank you very much.